Okay, so question number 4. How many valence electrons does magnesium have? What shell are they found in? Is this shell full? And is the magnesium atom likely to bond with other atoms? Why or why not? Okay, so to answer this question, first let's draw the electron configuration for magnesium. Okay, so the first step in writing electron configurations is to divide our periodic table into different sections. So we can divide it into the s orbital, which is shown in the light blue, including the helium atom here, and the p orbital, which is in green, and the middle transition metals is the d orbital, or the d block, and the last two rows, the lactanides and actinides, is the f block. So let's locate magnesium on the periodic table. So it's found here, atomic number 12. And starting from hydrogen, we move left to right across the periodic table, writing the row number, followed by the block letter. And to show how many electrons are in each orbital, we'll use superscripts. So every s orbital is able to hold a max of 2 electrons, and the p orbital holds a max of 6. Okay, so let's start to write the electron configuration. Starting from hydrogen, we write 1s2, and then 2s2, and then moving across to the p block, we write 2p6, and then we found magnesium here, so we just need to write 3s and then 2. So we can see here that there should be 12 electrons in total, which there are. And the question asks, how many valence electrons does magnesium have? Okay, so the 2 valence electrons are in shell 3. So we can say that therefore there are 2 valence electrons. They are found in the 3s shell. And is the shell full? The shell is full. Since an s orbital can hold a max of 3 electrons, or 2 electrons, sorry. And then the last part asks, is the magnesium atom likely to bond with other atoms? Why or why not? Okay, so yes, magnesium is able to bond with other atoms. And the reason for it is because its 2 valence electrons are likely to be donated to form ionic bonds. So for example, we can have magnesium bonding with 2 chlorine atoms to form magnesium chloride. We can have magnesium bonding with a single oxygen atom to form magnesium oxide, and so on, so forth. So the junior tutor said that magnesium belongs to the s block of the periodic table, or the 2 groups in the leftmost part of the periodic table. belongs to the third row, which indicates the energy level of its outermost shell, or the valence shell of the atom. Since magnesium is in the second column of the s block, thus it has 2 valence shells in the 3s shell. An orbital can hold a max of 2 electrons, and since an s orbital only has 1 shell, this means that the shell is full. Magnesium can bond especially with polyatomic ions, but for the halogens and the anions in a salt compound in a solution, it usually just gives off its 2 electrons to the anion, since it will be more stable giving off its 2 remaining electrons than completing the 8 for the octet. Yep, so this solution is correct. Typical compounds formed with magnesium can be magnesium chloride or magnesium oxide, just to give some examples. So it doesn't need to bond with polyatomic ions, especially because sometimes it can form these simple binary compounds as well.